Welcome to the next video. This one's going to cover questions numbers 16 through 23. So question 16, here we've got the graph of a quadratic function, and we want to find out what are the coordinates of the turning point of that function. So we can see from the y-axis that our parabola, our quadratic graph, comes down to -4. So that's going to be our y-coordinate. Our y-coordinate will be -4. So we want to find out now, what is our x-coordinate going to be? Well, our x-coordinate is going to be halfway between -1 and 3, because those are the points where it cuts the x-axis, as you can see there. A parabola is perfectly symmetrical, so how far something is from the left of the center is exactly the same as how far something is from the right of the center. So their halfway point between -1 and 3, that is where our x-coordinate is going to be. And we know that our y-coordinate is -4. Halfway between -1 and 3 is going to be +1, so our turning point is 1, -4. Part B asks, what is the equation of the axis of the function? So the axis of the function is, where is that center line? What is it evenly spaced from? All right, so -1 is 2 places to the left of the axis, and 3 is going to be 2 places to the right of that axis. So what is in the middle? Well, it's the x-coordinate of our turning point. So our axis is going to be where x equals 1. Question 17, we've got $40,000 being invested in an account paying an annual flat rate of 3.5% interest. What is the future value of this investment at the end of 4 years? Now, the main thing where people made mistakes here was where it says the flat rate. Flat rate means it is simple interest. So a lot of people were working out compound interest. You would have got part marked for that, so you would have got 1 mark, but we want to find out the simple interest because it says it is the flat rate. So remember, our simple interest is the principal times the rate times time divided by 100. So principal is the amount that we are borrowing, or in this instance, investing. So that's going to be 40,000. Our rate is 3.5%, and our time is going to be 4 years. So just substituting in those numbers, I can plug that into a calculator, and we get that our simple interest, this is just the interest, is going to be $5,600. So that's how much interest over 4 years our $40,000 is going to make. But the question asks, what is the future value of the investment? So it's going to be the $40,000 that we put in plus the $5,600 we make in interest. So remember, our future value is our P plus our simple interest. So that means our future value after 4 years will be $45,600. Question 18, the volume V of water in a tank in litres as it is being drained over time T in minutes can be modelled by the equation V equals 250 minus 10T. At what rate is the tank draining? So how quickly is the water leaving our particular tank? Well, there are a couple of ways that we can do this. The first is we can plug in a couple of values. So let's look at what is it initially. So when time is 0, T equals 0, so we can plug in that into our equation. So we know that V is 250 minus 10T. When T is 0, V is going to be 250 minus 10 lots of 0, which is 0. 250 minus 0 is 250 litres. So when time is 0, where we're starting from, we've got 250 litres in the tank. And if we look at our equation, V equals 250 minus 10T, that 250 represents how much water we are starting with. So if we had an equation, for example, V equals 500 minus 10T, we are starting with 500 litres in the tank. So that's when T is 0. Let's pick another point. You can pick any other point, but let's just do 1 to make our life easy. So when time is 1, we get 250 minus 10 lots of 1, which is just 250 minus 10. 250 minus 10 is 240 litres. So we've picked 1 minute the difference between 0 and 1. So in that 1 minute, how much have we lost? We've gone from 250 litres down to 240 litres. So therefore we are losing 10 litres per minute. Now, if we go back to our original equation, V equals 250 minus 10T, we've already said that that 250 represents the amount of water that we are starting with. that negative 10t represents the rate, right? So we know t is in minutes, and it says minus 10t, so that represents losing 10 litres per minute. So we don't have to do any maths by picking a whole lot of points. Just by understanding the equation, we can work out those answers. Whenever we've got a number that doesn't have a variable attached to it, that's how much we're starting with. And then our rate is going to be either a positive or a negative. In this instance, it's a negative, and that's the number that gets multiplied by our variable, in this instance, t. Part B of the question, after how many minutes will the tank have half the initial volume of water? Now, we've already worked out that it had 250 litres to start with, so we want to find out when will the tank have half of that. Well, what's half of 250? Well, that's 125 litres. So when will we have 125 litres? Well, that's when our volume, 125, is equal to 250 minus 10t. So we want to solve for that. So what I'm going to do is I'm going to take away 250 from both sides. So what I've now got is negative 125 is equal to negative 10t. Because that's my goal, is I want to get t by itself. So now I can divide both sides by negative 10, and we're going to get that t equals 12.5, and that's in minutes, so t is 12.5 minutes. So it's going to take 12.5 minutes for this tank to get half empty. Question 19, a photocopier was purchased brand new for $8,500. Using the declining balance method of depreciation, the photocopier loses value at an annual rate of 18.25%. What will be the value of the photocopier at the end of 5 years? All right, so we've got our declining balance rate. So that's basically the same as our compound interest, but instead of adding, we're subtracting. So what does that look like? Declining balance, our future value is equal to the present value, multiplied by 1 minus the rate, all to the power of t for time. So what's our present value? Well, that's our 8,500. What's our rate? It's 18.25%. And our time is going to be 5 years. So I can plug those numbers in. The thing we have to remember is that R needs to be a decimal. So 18.25, I'm going to divide that by 100 and get 0.1825. Plugging that into a calculator, exactly as you see that there on the screen, we get that our future value after 5 years is that our photocopier is now worth $3,103.54. Question 20. We've got 6 yellow birds and 4 blue birds that live in an aviary. They are feeding from a barrel. What is the probability that when only 2 birds are feeding from the barrel, at least 1 bird is yellow? Now, when we see probability of at least something, what we want to do is take away the probability of not that. So in this instance here, what's the probability at least 1 bird is yellow? Well, the probability that at least 1 is yellow is the same as 1 minus the probability that none of them are yellow, because all of our probabilities have to add up to 1. So if I add up the probability that none of them are yellow plus the probability that at least 1 of them is yellow, those two things would equal 1. So we now need to work out what's the probability that there are no yellow birds. Well, we've only got 2 birds feeding from the barrel, so that probability of no yellow means that the first bird is blue and the second bird is also blue. We need to work out those individual probabilities, and then we're going to multiply them together. So what's the probability that our first bird is blue? Well, we've got 4 blue birds out of a total of 10 birds. So the probability that the first bird is blue will be 4 out of 10. Now, when we come to work out the second bird, we've already pulled one of those blue birds out to be the first bird. So we had 4 out of 10, but as soon as we take one away, we're now left with 3 out of 9. Right, so the probability that the first bird is going to be blue is going to be 4 out of 10. Probability that the second bird is blue is going to be 3 out of 9. So I will multiply those two numbers together. 4 times 3 is going to be 12. 10 times 9 is going to be 90. So this is going to be 1 minus 12 over 90. Now, if you put that in a calculator, it will simplify it down for you. Otherwise, what we're going to have is 78 over 90. And then we need to say, well, hang on, both of those are even. What are our common factors? We can simplify that down to 13 out of 15. Don't forget, you can also just type in 78 out of 90 on your calculator, and then it will automatically simplify it down for you. Question 21. 5 boxes with varying weights are arranged from lightest to heaviest from left to right. The following data is given about those boxes. Mode is 0.6 kilograms, the mean is 1.2 kilograms, median 0.9 kilograms, and the range is 1.5 kilograms. We want to work out what is the weight of the contents of box number 4. All right, so we're going to use the fact that these are in order from lightest to heaviest from left to right. We can assign numbers to them based on that information. So the first thing we're going to look at is the median. Now remember that median means the middle score. So from boxes 1 through 5, the middle box is box number 3. That's our median box. So it's going to have a median weight of 0.9. So we can write that straight there. The next thing we're going to look at is our mode. Now remember that mode means it's the score that is most occurring, is more common, happens more often. Now we know that these are in order from lightest to heaviest, so therefore 0.6 is going to be to the left of 0.9. If we only had one box that was 0.6, well, it could be box 1 or box 2, but because it's the mode, it's going to occur more than once, so both boxes, box 1 and box 2, must both be 0.6 kilograms. Next thing we're going to look at is our range. So range of 1.5 kilograms. Now the range is how far are our boxes spread out from the lowest box, number 1, to our highest or heaviest box, number 5. So the difference between those boxes is 1.5. So if I went box 5 weight minus box 1 weight, I would get 1.5 kilograms. So I'm just going to do the reverse of that to work out the weight of box 5. So box 5 is going to be my lightest box, 0.6, plus my range of 1.5 kilograms, so that the weight of box 5 is 2.1 kilograms. All right, so all of those boxes were pretty easy to work out. Box 4 is going to take just a little bit more. We've used our mode, we've used our median, and we've used our range. The one thing we haven't used is our mean, and that's the one we're going to have to do. So remember, the mean is what we would traditionally call the average. It's where we add up the weight of all of our boxes and then divide by the number of boxes. So if I was to add all of those weights together, we don't know what box 4 is at this point, so let's give it a variable like x. So now if I go all of the 5 boxes, 0.6 plus 0.6 plus 0.9 plus x plus 2.1, and then I divide that by 5, that would give me my mean score of 1.2 kilograms. So now I need to rearrange and solve for x. So what I'm going to do is I'm going to multiply both sides by 5 to get rid of the 5 on the left-hand side. So then, and I add those numbers together, 0.6 plus 0.6 plus 0.9 plus 2.1, that equals 4.2. So now 4.2 plus 6, plus x rather, is equal to 1.2 times 5, which is 6. So if 4.2 plus x equals 6, I need to take away 4.2 from both sides to get x left by itself, so x is 1.8. So what that means is the weight of box 4 is 1.8 kilograms. Now it's a 3-mark question. A lot of people did well getting the first couple of bits of information out, but I don't think there was too many who managed to get all the way to 1.8 kilograms. Now there's no question 22, that question was dropped, so straight on to question 23. Now we've got details relating to the last activity of a building project involving 9 activities is shown below. Right, so our activity is A9, it has a duration of 8 days, its earliest start time is 12, so day number 12, and its late start time, the latest it can possibly start, is also on day number 12. Part A says explain why this activity is on the critical path for the project. So remember, any activity that is on the critical path, there is no difference between the EST and the LST. All right, if there is a difference between the EST and the LST, that's our float time. All right, and that means that we could delay activity 9 for whatever that difference is between those two numbers. But as our EST is 12 and our LST is 12, we know that this is going to be on the critical path. So explain why this activity is on the critical path. Our earliest start time is equal to our late start time. There's no float, you could have said that as well. Anything that I mentioned in there, that would have got you a mark. Part B, what is the expected duration of the project? So this is not talking about the activity anymore. We're now talking about the project. It's the whole thing, right? A lot of people just said, well, it's 8 because it says that's our duration. But this is the duration of the whole project. Now we know that we have to start on day 12 because our EST and LST are both day 12. So we're going to start on day 12, plus we've got the duration of this activity of 8 days. So we're going to add those two numbers together to find out the duration of the project is going to be 20 days. For part C, it says that activity 9 depends on two other activities, namely activity 7 and activity 8, and it wanted you to complete the boxes for the late start time. So this is just working backwards. So we know that our earliest start time for activity 9 is 12, so that's where we're going to start with both of them. So let's look at A7. We're going to start with 12, and we're going to take away the duration of activity 7. So the duration of activity 7 is 4 days. So we're going to have to take those 4 days away from day 12 when activity 9 starts. So 12 minus 4 is 8. So the late start time for activity 7 is going to be 8. Now for activity 8 down the bottom, what's our duration of that one? Well, that's going to be 3 days. So we're going to do the exact same process. We're going to start with 12 from activity 9, take away 3, so that our late start time for activity 8 must be 9. Part D says explain why activity 8 has a float time. Well, this is just the reverse of the part A. Part A was saying why does activity 9 have to be on the critical path? Well, that was because our earliest start time and our late start time were the same. Why does A8 have a float time? Well, that's because there's a difference between EST and LST. All right, so we could say that EST is not equal to LST. It doesn't ask for it, but we could go on to say it's got a float time of 5 days. That's just the 9, our LST, minus the 4, our EST, which is a difference of 5. Right, so activity 7 and activity 9 are both on the critical path because there's no float time. Both ESTs are equal to their LSTs. Activity 8, however, EST not equal to LST, difference of 5, that would be our float time. And that brings us to the end of video number 2.